Hello everyone, this is Heidi Trisha Santos from BS Math 2A, and for today's video, we will be talking about infinite series. So let's start. Before we actually proceed with infinite series, we will first define what is a series. So series means it is the indicated sum of sequence numbers. We use the sigma notation to denote the series. To further elaborate series, let's start with this concept. So we have S sub 1 is equal to A sub 1. Let's assume that A sub 1 is the first term of a sequence. Then we have S sub 2 is equal to A sub 1 plus A sub 2, wherein this implies that the sum of two terms is equal to the sum of A sub 1 and A sub 2. And this goes on and on until the nth term. So to summarize this, we have S sub n is equal to A sub 1 plus A sub 2 plus A sub 3 plus A sub 4 plus A sub n, wherein this is equal to the sum of A sub I as I goes from 1 to n. But take note, it does not really have to start with 1, and the variable I can be any letter. Also, S sub n here is called partial sum. The I variable means index, 1 is the starting term, and n is the ending term. To continue, in series we have two types. First is the finite series, which means a summation of a sequence that has an n. For instance, we have a sequence of 2, 4, 6, 8, 10. So if we will try to get the sum of the sequence using sigma notation, we must think of the formula for this sequence, and we know the formula is 2i. Now, we can just easily attain it by adding this, so the result is 30. Next, the second type is what we call the infinite series. So generally, infinite series means it is the sum of an infinite number of terms of a sequence. So as its name suggests, the terms we are adding has no end, or it approaches infinity. We denote infinite series as this. So this expression is read as the sum of A sub I as I goes from 1 to infinity. It is important to note that the sum of A sub I as I goes from 1 to infinity is really nothing more than a convenient notation for the limit as n approaches infinity of the sum of A sub I as I goes from 1 to n. So sometimes it is convenient to write the infinite series this way, so we do not need to keep writing the limit down. Additionally, we may also encounter words such as convergent and divergent in infinite series. So the difference between the two is that a series is said to be convergent when it approaches a certain value as the series approaches infinity. So here is the definition, wherein this notation simply means that as a series goes infinity, and it approaches a certain value, or it has a limit that is a constant, then it is convergent. Meanwhile, divergent series is a type of series that contains terms that do not approach zero. This means that the sum of this series approaches infinity. So now, to better understand what infinite series is, let's have an example. So here is the problem. Evaluate the sum of 1 over 2 to the power of I as I goes from 1 to infinity, and tell whether the series is convergent or divergent. So let's try to write down the first 4 terms, then plus ... and further simplify. So let's analyze this. If we try to add the first 2 terms, we will be having 3 over 4, which is equivalent to 0.75. Now, if we try to add 1/2, 1/4, and 1/8, the sum will be 7 over 8, which is equivalent to 0.875. But what if we try to add 1/2, 1/4, 1/8, and 1 over 16? What will be the result? It will be 15 over 16, which is equivalent to 0.9375. So what have you noticed? It's like as we keep adding the terms, the sum of the series approaches 1. So from this observation, we can say that the sum of 1 over 2 to the power of I as I goes from 1 to infinity is equal to 1. So the question is the series convergent or divergent? Well, it is convergent because the infinite series has a limit of constant, or it approaches a certain value which is 1. So that's all for this video. Have a nice day ahead.